Alright, so this is the solutions for the worksheet entitled Testing Claims About Proportions Using P-Values. Alright, so the first one here is about my guy Gregor Mendel and his pea plants. He claimed that 25% of the offspring from two heterozygous pea plants, which are ones that are mixed yellow and green, will be yellow. So we need the null and the alternative hypothesis. The null hypothesis here is that the percentage will be 25. The alternate hypothesis here is that it will not be 25%. Part B, because this is a not equal to, means this is a two-tailed test. And then they give us some additional information here. They say, when Mendel observed the offspring in his experiment, he found that 580 plants, 428 produced green peas, 152 produced yellow peas. The 25% should be the yellow, so that's the key number that we need here. And that's what we're going to introduce into the calculator. Okay, so let me clear everything out here so that we're starting fresh with nothing stored in the calculator. I'm going to go stat. We're going to do a test. We're going to do a one proportion z test. Okay, so we're testing against 25%. The number of yellow pea plants that we actually got was 152. The sample size that we took was 580, and this is a two-tailed test, so we leave that with the not equal to, and we calculate. Now the key number that we care about here is that p-value, which is 0.5. okay, so we're going to be testing against 0.05, right? Because that's the error that you get from 95%, so you would have a 0.05 error. 0.5 is considerably larger than that, so let's talk about what kind of conclusion we can draw there. Okay, so part C that we have here is that the p-value for this problem is 0.5021, which is what I got from the calculator. Note that the p here is 0.5021, and that's significantly greater than 0.05, which is the alpha that I'm testing against. So this is bigger than that. The p is larger than the alpha, which means that I fail to reject the null hypothesis. Now, in this problem, the null hypothesis is the claim. So we say that the data supports the claim that 25% of the pea plants are yellow. So this is an example where the data supports the claim. Alright, so that's number one. Alright, so let's look at problem number 2. Problem number 2 here is about M&Ms. The claim here is that the percentage of M&Ms that are brown is less than 13%, right? So part A, we need the null and the alternate hypothesis. So this is not an equivalence statement, so we're going to say the percentage is less than 13%. The null hypothesis would be that it is equal to 13%, right? So because this is less than, this is a left-tailed test, okay? And then we get our additional information. A QA manager pulls a random sample of 100 M&Ms off the production line and finds that 8 of them are brown. So this is what I can enter into the calculator. Okay, so I hit stat. I do tests. I'm doing a 1 proportion z test. I'm testing against 13%, 8 brown M&Ms out of 100, and I have a left-tailed test. Oops, sorry about that. Left-tailed test. So I go and I do my calculation. I have a p-value here of 0.0685. So let's see what that does for us. All right, so the p-value that I need for part C is 0.0685. Part D has that p-value being greater than 0.05, so I fail to reject the null hypothesis. Okay, but the problem here is that my claim is not the null hypothesis. My claim is the alternate hypothesis. So if I fail to reject the null, the sample in this problem does not support the claim that less than 8% of M&Ms are brown. So because the null is not the claim is the alternate, and I fail to reject the null, this means that I do not support the claim here. All right, so there you have it. All right, let's look at problem number 3 in this set. All right, in the third problem here, we have a claim about adults and whether or not they prefer the window seat when they fly. All right, so we need the null and the alternate hypothesis here. In this situation, the claim is that more than half, right? So that's going to be my alternate hypothesis, greater than 0.5. The null hypothesis then is the equal to 0.5. And this one is an example of a right-tail test because I have that greater than in the alternate hypothesis. Now, I have the additional data here, right? We have a survey of 806 randomly selected adults, and we found that 492 of them said that they prefer the window seat. So that's what I'm going to enter into my calculator. Okay, so I bring my calculator back up. I go stat, tests. We're doing a 1 proportion z test. We're testing against 0.5. The number of people that preferred the aisle seat was 492. The number of people that I sampled was 806. And like we said before, this is a right-tailed test, right? So we're going to calculate. And this time I get a p-value. Now if you look, that's 1.815 times 10 to the negative 10. So that p-value is really, 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 really tiny. All right, so let's transfer that over to the paper and draw some conclusions. All right, so let's drop in C here. And we got a p-value of 1.8155 times 10 to the negative 10th. All right, so part D here, that value, 1.8155 times 10 to the negative 10th, is way below 0.05, okay? Way below that. So we clearly have to reject the null hypothesis here. Now note, though, the alternate hypothesis was our claim. So if we reject the null in this case, we can say that the data actually supports the claim that 50% of adults, more than, sorry, the claim isn't just 50%, it's more than 50%, more than half of adults prefer the window seat. All right, so there's your complete test for number 3. And then we'll take a look at number 4 here. Okay, so they're giving me all the information at once in this one, but I can parse it out. The Hawkeye electronic system is used in tennis for displaying an instant replay that shows whether a ball is inbounds or out of bounds, so players can challenge calls made by the referees. In a recent U.S. Open, singles players made 611 challenges, and 172 of those were successful with the call, or 172 of them successfully had the call overturned. Referees claim that less than 33% of the close calls that they would make would be overturned if they were reviewed. So let's talk about the referee's claim here, right? The referee's claim is that it's less than 33%. So the percentage is less than 0.33. That's not an equivalent statement, so it goes in the alternate hypothesis. The percentage being equal to 33 is the null hypothesis. So that's part A of the problem. Part B, because this is less than, means that this is a left-tailed test, right? So part C is the part that we get from the calculator, right? That's going to tell me the key numbers here is that there were 611 challenges. 172 of those challenges overturned the call. So let's get out the calculator here. Okay, so we're going to go stat tests. We're going to do a 1 proportion z-test. We are testing against 33%, right? The x value here is 172. The total is 611, and it's less than, right? So we calculate, and we get a p-value of 0.00539. So let's get that over to the other sheet. All right, so the p-value given to me in this problem is 0.00539. That p-value, 0.00539, is way less than 0.05. So we're going to reject the null hypothesis here. Now, if I reject the null, remember, this is the claim, that the claim is actually it's less than 33%, which means part E, rejecting this one means this one's probably true. We say that we can say the data supports the claim, supports the claim that less than 33% of calls, close calls, would be overturned. All right, so there you have it. That's the 4 problems. Hope you're doing well with them. If you have questions, reach out, send me an email, do one of the drop-in sessions, and we will go from there. I hope you're happy and you're well, and we're gonna get through this together. There you go. Thank you.